Welcome to IP Day's Webinar Wednesday. Thanks for tuning in. Today we'll be looking at some GED math readiness topics, specifically word problems. All right. I am Harold Gertner, and like I said, thanks for joining me today. Here's my contact information, and it will be shared again at the end of the presentation, but please reach out with any questions you have about today's topic or other topics related to things we discussed. But also during the time that we're here together, if you have a question while we're working through the material, you can share those thoughts or questions through the chat bar. You all are muted today because we have so many folks joining us, but please feel free to use the chat bar. And yes, good afternoon. I see a few people tuning in already in the chat bar. Welcome. So let's get right to it. Today we're going to talk about word problems, and specifically related to the GED. Obviously, word problems are a big portion of the GED, and they're also a big portion of success in life in terms of further schooling and work and all those types of things. And as many of y'all know and have said, probably before to yourselves and to other students, word problems are where math meets the real world. Oh my goodness, I'm looking at the chat bar now, and we've got some people tuning in from outside of Florida. Wonderful. Welcome in. All over the place, it looks like. Sounds exciting. All right. Well, anyhow, we're going to look at, I'm going to, there we go. I just moved the chat just a little bit so I can not get completely distracted and sidetracked by all the wonderful places everybody is joining in from. All right, so back to the moment at hand. I could go through the list there and see where y'all are tuning in from for forever, but we're going to be talking about the ability to solve word problems as an essential skill for students in life and work, and specifically on the GED. And we're going to look at a few topics here: close reading and comprehension skills, a little bit of kind of the power of using estimation and an educated guess, particularly for a GED and timed testing environment, as well as hopefully I'll leave you with a few specific strategies that you can apply immediately. So anybody that's from Florida and has been able to join one of our in-person sessions this spring, we've had some word problem work already, and we looked at word problems as solving word problems and teaching them as their own packaged unit and a specific thing you focus in on. And today's webinar will kind of build on that concept by looking at a few more of these details inside of that larger process. So if you're teaching word problems as a specific skill in and of itself, separate from just the computational skill you are working on, then these are some of the other strategies or tools within that area you might want to focus on. Okay. And so one of those things would be some of the reading skills, right? Word problems can be difficult, many times more difficult than just math or just reading alone, because it is combining multiple skills. And students without strong reading skills are really going to struggle with word problems, right? And so there's this kind of double issue going on here where we have to work on students' reading skills as well as their math computational skills to help them successfully complete word problems. You know, math anxiety is a real thing, and it's a real thing for word problems as well. And so some students can be overwhelmed before they even start. And so hopefully breaking that down into a few steps that are a little more manageable and feel a little less overwhelming will help your students be more confident and more successful in their approach to word problems, right? And so one way to start with that, and I'm sure many of you do, is to identify signal words and key terms that might guide students into what sort of computation they need to do. Now, I say might because we all know that sometimes signal words can be a little bit misleading. And anybody that's been able to join us for one of those in-person trainings, we talked about how you can't 100% just focus on signal words and say, if you always see less than, it will always mean to subtract, because there could be a word problem written where less than really is used in a comparison factor and doesn't really mean, that's not really the function you need to do to get to the answer at the end. And so that's where the critical thinking and close reading comes in. But your students do need to be aware of all the different kinds of terms that could signal different types of computational maneuvers, right? Whether they need to add, subtract, multiply, divide. We don't need to teach them that these are 100% restrictive and this will always mean this, but that these generally will clue you in towards a certain type of process, right? If we see some total increase, we should be expecting addition. If we see difference, fewer than, minus, of course, we should be looking for a subtraction situation. But as we all know, that's not 100% always the case. But the first step is establishing what these words mean in most situations, and then pushing our students to use the close reading and context of the word problem given to figure out if that's precisely how they're being used in the immediate context. And so along those lines, here's some of those signal words, a pretty big list, not exhaustive, of course, but if we look across here, we can see some of these places where a signal word might clue to different functions, right? Each could mean multiply or it could be divide, depending on the way the sentence is worded. But our students do need to kind of go through the idea that it could be one of these two, and working through learning signal words as terms of what that function they might relate to is a good skill to build foundational knowledge for interpreting word problems. Same, if we look over these some more, we've got some other here where like less than could be a comparison between two things. Someone has less than someone else, or it could mean subtract, like many of our students will immediately think, okay? And so having these words right away and go, oh, less than means subtract. That might be their first instinct. But then as you progress, you'll remind them, oh, it could also mean that you're comparing things. And so we need to read the context a little further. We can't just see a signal word and jump to a certain type of mathematical function. But knowing those signal words and practicing interpreting them creates a solid foundation for that later critical thinking, a little more in-depth. Right? And so, of course, I think y'all probably know or have seen many of these before, and I'm sure many of y'all can think of many other options that might fit in to these different categories. Okay, and so one activity you might want to do with this is something I like to call a signal word activity, where really, instead of math for the day, well, maybe not the whole day, not the whole class, but for a period, instead of doing some real mathy math in math class, we might do a little more language kind of reading sort of skills in math class. So you might do something like this, where you provide your students with a word list, maybe mixed up words, right? Some signal words, some things that aren't signal words, some things that could fall under multiple categories, right? You could throw in some phrases too. It doesn't just have to be individual words. But then ask students to go through a sorting activity where they sort the words into various categories. Is this a signaling addition, subtraction, multiplication, division? Is this signaling an equal sign, or is this signaling a comparison or of sorts? Or is this not a math word? All right, we're dealing with word problems, and sometimes a word that might normally mean something in a math situation might not really be a math word, or there might be other words thrown in, things that we need to get rid of that we would immediately say, oh, this has nothing to do with math. And if you look at the example of the word list I threw up here pretty quickly, you can see a few things like quickly and behind that are not necessarily math words, right? And so, yeah, you could have behind maybe used in some sort of discussion of the order in which people are sitting or the direction between one fence and another or something. Or maybe you could have something where they're discussing how quickly someone moved down the road, but that's not the math piece you want to focus on, right? But it might sidetrack your students for a minute. If we're talking about the speed of a car, how quickly the car went, it's not really a math word, but it might sort of be telling you equals. We're looking for how fast it was. The answer is the speed. It kind of, the car equals this amount of miles per hour. So you can kind of play with some of those things, but have your students sort them, and then in a little group, a little think, pair, share kind of moment, have them share together about their answers and why they sorted certain things into different categories. You might have something fun where you get some people putting less than in a comparison category while other people putting less than under subtraction. And then you can have some discussions and they'll remind themselves that that could be something that could fall under one category or another, because depending on the context, it could mean something slightly different. Then taking it to the next step after this, after they've practiced with some word problem sorting of signal words and key phrases, give them some word problems, not to work out, but to first highlight all the signal words and then to suggest exactly what problem or what function they might need to do to work it out. In other words, highlight the signal words and then make sure those signal words are actually signaling to do what they have guessed that they are, and confirm that their suspicions as to what less than in this situation meant was true. Okay. And then if you want to go further, you can have them solve the problems. But sometimes it can be quite fun, especially in a math class when some students immediately come in thinking it won't be fun, to give them some work to do that doesn't include numbers necessarily. And then they feel very surprised and off-put for a few moments, and it can be an exciting, healthy learning environment. And then you add the rest of the working out the problem back in. But this is really analyzing the paragraph that is the word problem, much the way you would critically analyze or close read, actively read a paragraph in a more RLA, social studies, science sort of environment, right? We're just looking at the words and the context more than the actual math functions at this point. Any initial thoughts or questions about that sort of approach? Anybody ever played with teaching just signal words and their meanings in this kind of environment without the math? Not, we're working on addition, let's learn addition signal words, but here's all kinds of signal words together. Let's identify them and sort them. And all right. Maybe not. Well, hopefully this is a new idea for some of y'all and something that sounds like putting in into practice, like the activity word scramble. Exactly, like a word scramble, definitely. Signal words are great first step. I agree, to helping them solve word problems. Exactly, that's what we're getting at. And the key here, though, is to teach signal words as their own unit together, instead of we're working on addition, now here's addition signal words. We're working on division, now here's division signal words. This way, you're having to sort and identify exactly from the student's own efforts which function these words identify, instead of already being in the addition lesson and knowing, oh, all these words go with the addition. That's more of a passive connection for the students, if you will. But excellent. All right. Well, let's move on from there for a moment and see what we've got going on here next. So this is a little more after identifying the signal words. You want to turn these words into some sort of math problem. Okay. And again, you're going to have your students read the problem carefully and identify what's being asked. maybe this goes back to that highlighting the important information. Just highlight the signal words quickly or underline the signal words quickly, and then read more closely to make sure they're telling you, or the student reads more closely to make sure they're telling them what they believed it was telling them to do, kind of confirming their suspicions. And then rewrite the problem in a simpler way, right? John has 3 times as many apples as Sarah. Well, John has something more than Sarah, or has something related somehow to Sarah's. So John equals something that Sarah has. We might pull that has out as a signal word, right? 3 times, there's some language that we want to remind our students how to turn that into math. Well, John has, down below we have John equals, right? 3x, so 3 times, right? We're not quite into algebra yet, so I'm still using an x for a multiplication. Even though I could, we should probably introduce a dot or some parentheses here instead, right? But you can work with me for a second. And so he has that many more, as 3 times as many as Sarah. Sorry, I'm getting a little tongue-tied here with all these apples that John has. And then so you've already the students already kind of stepped it through, and they've identified the main signal word of times as many is multiplication, right? Times. And they've identified has as kind of an equation signal. And so then it becomes, well, if Sarah has 4 apples, oh, plug that in on Sarah's side, because it was John equals 3x, 3 times Sarah, right? And then 3 times 4 is 12. So obviously John has 12 apples. And I know that was a very simple sort of word problem and example, and that many of our the word problems on the GED, of course, are going to be much more complicated and multi-step word problems. But it's nice to start this process out in with simpler language and simpler steps to get in the habit of how to translate the language into the numerical problem, right? Excellent. Okay, yeah, and here's something else. Another step kind of in the same line in the chat. Mildred shared that they've done something similar where they read word problems and ask what problem or what you would use to solve that problem. Like, what is the main step that you need? And again, a great one, a good foundational move, kind of like this. What's the one major step we need to pull out of this story about John and Sarah? Well, we need to do some multiplication. When we continue to ratchet this up to be a little more difficult for our students as we continue to prepare them for the GED by, slowly making things harder and giving them that good scaffolding to get there, we'll have to identify the probably 2 major functions you have to do in a function, because in a word problem, because they're often multi-step problems, right? And yeah, and so this is a great simple way, if you're going to turn it into a real straight up equation, to solve the equation after you've changed it from the words. Okay. Another great tool for word problems and good for working with students. I believe maybe it's coming up in a second. Sorry, I got myself a little off topic for a second. There are off slides, but I wanted to touch on the idea briefly here that we can also turn these signal words or word problems into drawings, right? This equation that we wrote out of John being equaling 3 times of Sarah, we could have drawn that out in apples, right? Question mark John, how many apples does he have? Well, that equals some amount of apples that Sarah has. And we could have actually drawn these things out. So writing out the equations or drawing them out are both good steps towards building those words into something you could solve for the students, right? Now, another good step is estimating, right? Estimating is a great skill, especially for a timed test, but also in life. Estimating and doing quick math in their head, if they can, is something students will use a lot more in day-to-day life than some of the more complicated math skills we need to teach them for the GED. And it can also help quickly confirm that an answer is pretty close on the test. Does this seem like a reasonable answer or not? Right? So good estimation and the kind of steps you want to take for that and encourage your students with would be first rounding numbers to make calculations easier, right? And looking at the example below, we have a store sells 47 packs of pencils for $3.89 each. How much will the total cost be, right? Well, I could multiply that out, but it's going to take more time and than if I estimated it. Okay, now, why might I estimate one way or another? Well, my students are generally going to say, okay, I can understand why we rounded 47 to 50. That's the closest to the 10 spot. That's clearly the closest number to round to. The 7 makes the 4 go up and whatnot. But why did we round 389 to $4 instead of 389 to 390? Some of my students will be fixated on rounding to 390. Can anybody guess or explain why that doesn't help at all? I mean, it's proper rounding. I'm not going to tell anybody that's incorrect. That is the closest to a 10 spot. And many people want to round an 89 on up to a 90. But that doesn't make my math simpler. Rounding to $4 makes it really easy to see. Oh, here we go. We got a chat. Yeah, it's about the quick visual. That's a good description. Excellent. I like that. Yeah, so 40 or $4 times 50 of them makes it very easy to see we're talking about around $200. Okay. And then what we have to remind our students is to think about, okay, now as I look to my answers, did I round up or down? Well, I rounded both of these things up. So should I be looking for a number that's a little higher than 200 or a little lower than 200? Should I be looking for something around, I don't know, say I had an answer in multiple choice test that was 225, 240, 200, or 182? Well, if those are all my answers, I know right away that 182 has to be the answer. Because I rounded both of my numbers up, I'm looking for the one that's down below the 200 that I got for my estimate, right? Now, usually on the GED, it won't be quite that easy, but often you can estimate on many problems in this kind of fashion where the students can throw out at least 2 other answers that are clearly too far away. Like maybe in the little example I just gave me, it would have given me 182, 190, 215, 225. Well, then I can throw out the 215 and the 225 because I know they're more than the 200. But I might have to do a little more precise math to get the exact answer at that point. Or if I'm in a big hurry, I can at least answer one of those 2 as the answer, flag the question, know I had a 50-50 chance of guessing the correct answer, and if I have more time, come back and work out the actual problem the rest of the way later, right? And so it gives you a quick, reasonable answer that you can make some guesses. If, again, oh, I see that there, right, in the chat, the idea is understanding the logic of the answer, if the answer is logical or not. And that's exactly what we're getting at here. And unfortunately, many things to many of us as instructors that seem instantly logical may not seem logical to your students. Like a student might make a mistake with this and accidentally write down $2, put a decimal in there, 2.00, right? Well, we know that 50 times $4 is not going to equal $2. But you might have to talk through with them that look how far off this is. This isn't reasonable. One of the things costs more than $2. One of them costs almost $4. That's why we rounded that. And initially, especially if students have a little bit of math anxiety, which many of our students will, they won't have the immediate logic or they won't have the confidence in the logical answer to question themselves. They won't have the confidence to say, oh, that's not $2. I must have gotten $200. Or if they got a decimal in the wrong place, it's not $20, it's $200. And so we have to help them see that and step it through. Another thing that's good to do for estimating is getting used to really common percentages and things, and like halves and quarters, and be able to know if somebody's talking about a quarter, you can just divide by 4, right? Or if halves, divide by 2, or 50% divide by some of those simple. Not that they need to memorize every percentage and every fraction equivalent and things of that, but some of the most common ones can help make word problems and estimation easier. And then again, of course, breaking it into simpler steps can help as well. What if we had 2 pieces that this was a multi-stepper, and we had pencils at this amount and erasers at another amount, right? We might break one step down into 200, break the other step down, and then have an easy addition for an estimate, right? Yes, does this answer seem reasonable is the question to ask. Exactly. Great. Good. Thanks for the chat participation there, everybody. And so that adds into this. Really, educated guessing is talking about the reasonableness of an answer, kind of like y'all were just getting at. And so y'all are a step ahead of me already. Much like estimation, or kind of a combo or a cousin to estimating, educated guessing helps students increase their speed, their confidence, and therefore hopefully their success on the GED and math and other situations, right? We already kind of spoke about this, but one good first strategy is to eliminate answers that are clearly wrong. And that can be for a variety of reasons, right? Like something, well, in this example we have over here at the side, I might notice that if a car travels 250 miles in 5 hours, what is the average speed? Well, just from everyday knowledge and being around the world, hopefully I know they're not going 10 miles an hour, right? Hopefully I could throw that out, because that's just, it seems clearly incorrect, right? Other things we could do, things that happen sometimes. What if this answer was about, this example question rather was about the area of a carpet that needed to be installed in an office. And 2 of the answers were in square feet, and 2 of the answers, or one answer was in feet, and one answer was in cubic feet. Well, hopefully, if we discuss about kind of common patterns that you might see in certain word problems and ideas or answers that are clearly incorrect, our students will get used to the idea that, oh, it's an area. Area means I'm covering something. I'm covering something, I'm square feet, right? And therefore, they could throw out the straight feet answer and the cubic feet answer, because the straight feet without a square, just feet to the 1/1 power, I guess you'd say, right? Technically, is probably just for a perimeter and enclosing something, that kind of language, right? Whereas the cubic feet are for filling things, right? We might be talking to the HVAC crew about the office we were getting the carpet in if we wanted to talk cubic feet. How much cubic feet of air is flowing through here? But square feet, we should know, is the area answers. And so we could zoom right in on things that are clearly possible answers and throw out things that are clearly incorrect based on a little bit of that kind of general knowledge. Good quick question and the answer, yes, you can have a copy of these slides, and they'll be available through IP Day in the very near future. But back here again to what we're looking at. Another thing, you can substitute numbers, plug in simpler numbers to make your, well, as it says here, or make your numbers simpler. So sometimes that might mean chopping zeros off of something, right? If I've had 2,500 miles in 50 hours, I could get rid of some zeros and still have the correct proportions to work out the problem properly, right? But it would make my numbers smaller. Even if I'm using a calculator, if I can shrink my numbers into something smaller, it's less likely a chance that I'll accidentally hit 3 zeros instead of 2, or make a mistake typing something into my calculator, even if it's during that period of the test. But simpler numbers can help test possible solutions and give you an idea as if you're on the right track, right? And then, of course, we already mentioned reasonableness, the idea of things that are too large or too small. We have to encourage our students to remind them they do have some math sense and some math logic, and to not fall into math anxiety and go with that instinct that 100 miles an hour, that person's moving way too fast, because that would only take me like 2 hours or so, right? That's the way our students would say it. 250 miles, 100 miles, that's only 2 hours or so, right? And then, but the other side of things, they might say, like we mentioned, 50's too, or 10's too slow. But now we've got the 25 and the 50 that we have to work through a little bit more. And through a quick estimation, the 50 miles an hour would make the most sense. And through simple math is clearly the right answer as well, right? All right. So a few more kind of strategies building on what we've been talking about. Breaking problems into steps is a great way to go about things. And by that, I mean, teach the students to read in chunks rather than the whole thing. Sometimes the whole multi-step word problem can be overwhelming. But if you read kind of sentence by sentence and highlight the signal words you come across, or make notes of the important details that are popping out, or start to draw your picture that goes with it as you go, it helps increase engagement with what the student's reading and understanding. They're actually thinking about, what's this number telling me that's built into this word problem, instead of just zipping through, right? Another good example or good approach with that is, when you're breaking problems into smaller steps and chunks, is read backwards. Sometimes reading a word problem backwards can help students focus on the individual pieces, individual sentences, and help figure out what's most important and what else is extraneous information. Because you start with well, not the answer, but what you're looking for. Here's what we're looking for. And then you work your way back and find which of the pieces of information, as you work your way back, are smaller chunks that can contain the important piece you're looking for, right? Great way to get people involved with reading word problems and answering them correctly is use everyday relatable stuff to build this part of the math. We're not just doing random abstract critical thinking, logic building algebra with X's and Y's and whatnot. We're creating a budget for an imaginary business, or we're working up something we might actually cook later this week, or figuring out shopping prices and discounts, or you can create a variety of things to meet your students in something that they're interested in with word problems. And if you don't have a whole lot of time to create those word problems, I'm not a huge champion for it, but I have been trying more and more to use a little bit of ChatGPT and some AI offerings to help create some of these types of things. And you may have to tweak them and get them just like you want, but instead of having to think up the entire scenario for a word problem related to X, Y, or Z topic, you can try that out if you're interested and see what it spits out. Again, moving further down our list, verbal reasoning is encouraging students to explain out loud what their thought process was. That's what I mean by verbal reasoning. Verbalize what they're thinking, what the process is. It reinforces that active reading kind of approach to word problems and increases deeper comprehension. And it's a good tool, good way to get the students more engaged in what the word problems are telling them. Multiple approaches is important. I knew I had this written somewhere. Yes, I like the idea of using visual models and writing out the full, like, very algebraic equation type way to solve a word problem. For some of your students, one will feel much easier and more familiar and more comfortable than another. And certain problems, it's easier and quicker to draw a drawing and use a little quick logic. And other problems, it's better to write the full equation out. So it's nice to practice both with your students. and teach multiple ways to solve any one problem, that there's not always a quote right way to do it, right? And then of course, the only way to really prepare students for word problems is to practice, 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 repeat, 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 and mix the word problems that you work on, much like they will be on the GED. Word problems will not be, here's a list of addition word problems, here's a list of percentage word problems, or even we sometimes get a little too detailed and focused. Here's a list of increasing percentage word problems, right? Or something like that. We need to give them a much more jumbled variety of word problems like you would get on the GED itself, where the difficulty is mixed and the content and subject areas are mixed as well. Okay, so another thing you might want to do, another way to kind of engage with word problems with your students and have them dig a little deeper into what is going on with them, is have them work together to break them down and solve them, and work together through that process that you've just mirrored maybe and we've been talking about in these last few pages, right? Divide the class into small groups, and then either individual groups or for the entire group, you can have a multi-step word problem that you're sharing with them, and then have them work as groups to identify the signal words, discuss the best ways to solve that, either with equations or drawings, or maybe different individuals in the group present different ways to each other, and then to solve it together. Maybe even if they've come up with different approaches, one with an equation and one with a drawing, they can both solve it and then confirm that both ways worked and that they both got to the correct answer together. Again, this is just another way to engage students more deeply with word problems and analyzing them and approaching them as their own, teachable moment or subject area. Right. And then, of course, you can add competitions to make it more fun for students at times, speed rounds, those types of things. Right. Okay. Great. So we're going to just have a little interactive thing here together for a few moments. If we're looking at this first problem, I want you, some folks, if you feel like a quick typer, share a few signal words you might see in some of these questions. So question 1, 2, or 3, share a few signal words in the chat bar that you might notice. Excellent. Lots of good ones coming in. Yes. Per, total, how much, in total, per, hour, total, already has, how much, excellent, each, exactly. Y'all are picking on all kinds of things. And if you'll notice, some of these things, like each is one of those that could signal a variety of functions, right? Total is gonna hopefully signal our kind of our final answer of something equals something, right? But so might has. The farmer has 240 apples in each box, and then that's going to equal some other, or some other scenario. I don't know. I should read a little deeper here, but yeah, so excellent. Y'all identified some great ones there. And again, we would translate this to math either, and when I say translate to math, I mean either drawing the pictures or writing out the problems, right? So I might have something like, in this third question, a theater charges $8 per adult ticket and $5 per child ticket. If the family buys 3 adult tickets and 4 child tickets, how much do they spend in total, right? And so I could write down a couple of things I could do. One student who's already comfortable with algebra might go ahead right away and say, okay, well, I have $8 per adult ticket. I have 3 adults. So let's multiply those together. And let's put that in parentheses because I want to do that before I add it to the children's tickets. And they'll jump right to seeing 5 times 4 will give me that. And I'll add those together. But someone else might do something like, well, I have $8 per an adult. Here's $8. Draw an 8. There's 3 adults. Well, let's write 8, 8, 8. So I have 3 8s, right? And then I have four children. Well, let's write down a 5 and a 5 and a 5 and a 5. Now, what do I do with all those numbers? Well, those are all the people going in. We have to pay for everyone. So let's add them all together, right? Someone else might draw out tickets with A for adult on them and 5 tickets with C for child on them. And then sub in 3 with an A on them, and then 4 with a child on them, and then sub in the price that each of one of those costs. And those would all be proper ways to kind of translate the words here into the math that needs to be done. Now, clearly, many of us and many as math teachers would want to see the very first one first. Or maybe not first, but that's our main goal. We'd love to see parentheses 8 times 3 close parentheses plus open that parentheses 5 times 4 close the parentheses, and then have them work it down to 24 plus 20 and 44, right? When they add those together. But we need to remind and encourage our students that all those different kind of drawings or ways I interpreted it for you there would be proper ways to understand what to do and would help our students get to the right answer, right? And let me see, a little chat came in. I missed something. Yeah, and then we would add, exactly. Now, I don't really have any multiple choice questions here for you. But again, this is where the estimating and educated guessing would come in best, would be when you have multiple choice questions, you could quickly estimate things and then make educated guesses from those options, even if that means throwing a few out and just having a few to guess from, right? Even if you can't get down to the exact single best answer to guess for. Okay, so really the key takeaway for this short dive into word problems is that identifying signal words is the best way to figure out exactly what operation you have to do. It's really the only way, but that working on that as its own individual skill can be a kind of fun way to get into math problems and into word problems without scaring your math anxiety-ridden students too much on the first day of word problems. We want to translate those problems into some sort of mathematical equation. And I really maybe should have used a different word there because I mean more broadly, like a drawing could be a mathematical equation for the right students, help them figure out what to do to get the right answer. A formal equation, like we talked about, would be great. And many of our more advanced students, or as some of our students advance beyond just needing the drawing only, they can do that. I love making drawings for word problems, even if I turn them into a good formal equation at the end anyway. So many of these skills overlap, of course. Estimate to help check for reasonable answers, and that leads right into educated guessing when the students aren't sure. And encourage them. We're not necessarily teaching to the test, but we want them to be as successful as possible. And so we do want to encourage some good test-taking techniques, like making an educated guess off of a quick estimation and flagging that question to come back to work through later if you have more time, right? Also, just closing down here, it's important, again, to solve word problems with a variety of techniques and a variety of contexts, all mixed together, right? It doesn't help our students as much to identify the large umbrella topic area that we're working in, like percentages, mean, median, mode, multiplication, addition, and then introduce word problems under that. It's more helpful to introduce those individual computational skills and then present word problems as a jumbled mess from all of them together. After, of course, we've done some real specific skill building on how to interpret those word problems, right? We will have another webinar coming up a little later on this summer, digging further into active reading, critical thinking, and word problems. So stay tuned for that. And if you have any additional questions, now would be a great time to throw those in the chat bar, or if I missed something, please copy and add it back in. Oh, thanks for the kind remarks already. I appreciate that you enjoyed the session and found it helpful. If you do have other thoughts later, you can follow up and send me a message at hgertner@floridaipday.org. And if you wouldn't mind hanging on for just a few moments, we'd like your feedback, please. Thanks again for joining the session today. Oh, yeah, and while you're working on your feedback, again, thanks for joining today's session, and I'd like to remind you of the next Webinar Wednesday. We've always got a few Webinar Wednesdays each month for you to gain some great training here from IPDay. The next Webinar Wednesday will be May 27th, and it is titled Teaching Adult ESOL in Corrections Education. So specifically geared at those corrections folks, but I'm sure there'll be a wealth of information for folks in and out of the correction system. And of course, as always, you can find the information to register at through your IPDay portal.